This is the first video on chapter 36, absolute extrema and the extreme value theorem. Now, the extreme value theorem is corollary 284 in the notes. It says that a continuous function on a closed interval has an absolute max and an absolute min on the interval. And then theorem 285 tells us that the absolute extrema guaranteed by the extreme value theorem occurs at either the endpoints of the interval or the critical points for the function. And remember, a critical point for a function is a place where the function exists, but the derivative either doesn't exist or is zero. Our first example, we're going to find the max and min of this function on this interval. F of x, x cubed minus 3x plus 1 is a polynomial. Polynomials are continuous everywhere. A continuous function on a closed interval has a max and it has a min. Polynomials are also differentiable everywhere, meaning the only critical numbers for a polynomial are the places where the derivative is zero, because the derivative exists everywhere. So we want to find the absolute max and the absolute min of f on this interval. So we start by calculating the derivative. So we just use the power rule all the way through, 3x squared minus 3. We factor this to find the critical numbers. So x squared minus 1 factors as x plus 1 times x minus 1. So our two critical points, or our critical numbers, are negative 1 and 1. So we test 0, f of 0 is 1. We test 2, f of 2 is 3. These are the endpoints. Then we test 1, f of 1 is negative 1. So we have a min at negative 1. We have a we have a min of negative 1 at 1. We have a max of 3 at 2. Why did we not test negative 1? We did not test negative 1 because it's not in the interval. So we're looking for the max and the min on this interval, and one of our critical numbers was not in the interval. So we did not see what f of negative 1 is because it doesn't matter. Our second example, we're going to look at part E of this example. G of x is a trig function, so we have a sum of trig functions. So we have sine of x plus cosine of x. Sine and cosine are continuous everywhere. They're actually differentiable everywhere. Remember, differentiable functions are continuous. So the sum of two continuous functions is continuous, so we have a continuous function on the closed interval 0 to pi. We calculate the derivative because we want to find the critical numbers. So the derivative is cosine of x minus sine of x. To find the critical numbers, we solve this equation. We set the derivative equal to 0. Sine of x is equal to cosine of x. In the interval 0 to pi, there's one solution, and that's pi over 4. In general, this equation has infinitely many solutions. But remember, we're restricting our attention to the closed interval 0 to pi. So we have our critical number, or our critical point. So we'll test our function at the endpoints. I always start at the endpoints because those are the ones you're most likely to forget. So g of 0 is 1. G of pi is negative 1. Then we test our critical point. G of pi over 4 is square root of 2. So we have a max of square root of 2 at pi over 4, and we have a min of negative 1 at pi.